Again, if you're just watching over YouTube, you can go right here to whitehatacademy.herokuapp.com and enter in your email, not an email at White Hat Academy, but just any personal email that you can confirm. And then you will be able to register for our Slack group, where we're able to ask questions and share resources afterward and so forth. You can also, and I would encourage for now for this meetup, just watching this time around, because we're going to go through a whole bunch of stuff. But afterward, or as we're just getting started, you can head here, and this will allow you to go through all of the live labs that we're going to use for the exercises this evening. On your own time, as many times as you like, play around with them. You get your own terminal to a server and a web application. So it's pretty powerful stuff to play around with if you go to ex.whitehat.academy. And so that platform is here. Just to show you around really quickly, we have a few different modules beyond just web applications and secure coding. If you want to practice your bash scripting, or we have a few more things on specific security tools, Metasploit practice, you can dive into those lessons as well. We have a pretty broad smattering of all sorts of fun things you can try out. TCP dump, some network focused stuff. We just posted one for the Apache struts exploit, which is what got Equifax back in the day, not too long ago. But I'm going to stick with just this web apps page. With the meetup a while back as part of the conference, we went over reflected cross-site scripting and SQL injection. There are both lessons and challenges, so the lesson will take you through step by step. The challenge will not tell you what to do, or rather it will tell you what you should do, but not how to do it, so you can get some extra practice that way. We're going to go through this lesson, and depending on time we might get a chance to dive into this one as well. This is Flask based and this is Django based, but they're both Python based lessons, although it's more about the concept than the specific framework. So unless there are any quick questions, notes in Slack, I'm going to dive right in, and we will get to taking a look at this first lesson. So again, I encourage you to just watch this time around, and you can always go out here. I'll put the link in Slack as well, so that you can practice this on your own time. Repeat all the steps, make sure that you really got the concepts down. So I have a terminal to a server here, and I've booted up my own personal web app. You don't need to copy this down. This will be different for you when you try it out later. But I'm just going to open that in a new tab. So this is my web application for my first set of exploits and patches practicing. It's a very simple application that just allows me to upload an image, and then I'll be able to view the image. So you don't need to pay too much attention to this. This is really what I'll be narrating in terms of the content we'll be going through. But the first thing we're going to do, we're going to demonstrate a couple different possible vulnerabilities here: directory traversal and stored cross-site scripting. We'll get into what those mean and what they mean in a security context. But the first thing we should do if we're doing any sort of security testing of an application is really just test out how things are going here. So in expected functionality, we should be able to upload an image. So let's try that out. There we go, and it displays it for us. Let me put up the developer console here. So you can also do that just by going to View Developer Console. Firefox has a very similar set of features down here. So besides the console, there's also a network tab, and I'm just going to take a look at what's happening across the network in terms of what requests and responses there are. So I'll refresh this page with the network open. And you'll see two things are loaded here. This first one is the image, and this one here is a /uploads endpoint. So if I click on that, we can navigate to that directly to see what this is about here. Let's get rid of that. So this is an endpoint to give me the actual image itself. So here we were on /view/name of our image, and here we're on /uploads, and then after the question mark we have query arguments. So file name is equal to small-image.jpg. Just taking a quick look at Slack. Oh, I patched yesterday. Yes, I will post the link for that lesson as well. So our first hint that we might have a vulnerability, or we might have something at least to investigate here, is that I uploaded an image named small-image, and it didn't rename that at all. It kept exactly all those characters for me. And even more worrisome than that, this isn't necessarily a sign of a security hole yet, but it points to that there might be something here to exploit, is I now have this as a file name argument with the exact same name that I supplied it. So now that we've tested expected functionality, let's test some unexpected functionality, some places where things might break. We're going to go straight to this file name parameter. And what happens if I give it some garbage? And there's probably not an image named that. I get an internal server error, so that tells me it's not doing great checking. There's no user-friendly warning there, although it's not giving me more information than that. I might just start guessing at, depending on the application, some common file names that I might expect to find on this server. And sure enough, this was a bit of a contrived example, but I found someone else's image that was already there. So this is a really common security hole, in that this page itself might be protected, but if the actual endpoint that's fetching the image, fetching whatever assets that get loaded in here, is not protected, not checking, does this user have access to this file, I might just be able to get to it directly. And especially if I just start guessing at names, I might be able to get there very easily if there's no rate limiting involved. Let's test out some other things. So I'll return to uploads. What else could we test? We could try uploading without choosing a file. Nothing happens. It could have maybe broken, given us something interesting. Let's try uploading this .md. It's just a text file, but it's certainly not an image. And it worked. Let's see if we can get to it. So sure enough, this was my text file that's now uploaded to the server, and others can access it. This might be a stored cross-site scripting bug now, because I might be able to, for instance, have a file that executes code. Maybe it's JavaScript, or an actual executable file for a Windows system, .exe. If I were then able to point an unsuspecting user here, they would say, oh, it's White Hat Academy, I trust them. So I'm going to go out to this file, and it'll automatically execute code stored on my server now. What else can we do? Let's try maybe not having an extension at all. Or let's try some special characters. So if I make a copy, this now has a space. So what about a file name with a space in it? Well, that worked just fine. And if I click in through here, you'll see the uploads also didn't rename it at all. This is another good sign that it's not changing any special characters. And so I might be able to include special characters that cause it to interpret my file name as code or as a more complicated path, other than just a set of letters and numbers and a dot. What else can we try here? Let's try it without any sort of extension. Ah, this is trying to help me. Thanks, Mac. Sometimes you have to battle Apple a bit, so let's just change into this directory. And all I'm going to do is copy this into a file that doesn't have an extension. I'm testing out, does this search for anything that has a dot in it and accept it from there. And so that gives me a server error, which is interesting. It looks like it's trying to do some sort of file type check, but it might not be working correctly or fully as expected. Let's see if it has any blacklists in terms of types of files that shouldn't really especially be uploaded and run. Let's just change that into an exe. It's not a real executable file, but it'll look like one, and hopefully it blocks that, but it doesn't. It loads that just fine, so I can store things like exe files, probably JavaScript as well. So we've already found some serious holes in terms of stored cross-site scripting and such. Another thing that we might want to test is very large files. So uploading something absolutely huge might cause a denial of service. You should always be checking maximum file sizes for any sort of upload, even if that's a field with text in it. Any sort of form where you're expecting user input should have a sane maximum there. In this case, my server is going to block you from doing anything too crazy there. But we'll take a look at that later. So what we're after in this particular example for directory traversal now is the etc. password file. So what's that? Let's go to the terminal. Oops. If I just look at the contents of etc password, this is a file that lists out all the usernames in the system, including some information about things like what's their shell. This could be really useful information for an attacker, so it shouldn't be shared. In this case, I am the user named Whitehat, and so it would, attacker getting this file would have that information, might be able to leverage that into some sort of more complicated attack. So this is an internal file that we don't want anyone having access to, but we're now going to get access to it by using directory traversal. So what does that mean? It's called the .. attack sometimes because it usually means that it usually involves entering a lot of .. slashes. So what a .. does, if I print out the current directory, I'm just in home whitehat web is my current folder here, and at the terminal, if I do change directories one level up, that's what .. means. I've now gone one level up to home whitehat. So I can go back to web. I can do it twice now. Go 2 levels up, .. etc. I'm now at just the home directory. So we can use this to start navigating around the back end of the file system here. Just another quick example, if I were to do .. web, I wouldn't change directories at all because I've gone up a level and then back down into where I am. The idea here is the uploads are being called from some file in some backend server. We don't know what that, or from some folder in some backend server, we don't know what that folder is necessarily, but with enough guessing, usually not a lot of guessing, we can figure out how to navigate around to the folders that we want and that we know to expect on the system. So in this case, we're trying to get to the root level etc. file or folder. We just need to choose the right number of levels to move up from wherever our uploads are being stored and called from. So we're going to go straight out to uploads, and since we saw it's not changing any characters, it's not limiting us, the only thing that we need to worry about here is, does it interpret and keep all these .. slashes properly, or is it escaping them? Is it treating them as just characters? So we'll start out going up one level, which is, if we were in one folder down from the root directory, we could get to etc. password. No such luck. So we'll keep working our way up. We'll go up 2 levels. No luck. Let's go up one more, and this is going to do it, so watch carefully here. If I go up 3 levels and then etc. password, once I go here, it goes back to my previous URL because I've now downloaded a file here. And here it is, the contents of the backend server's password file. So, how did we get here? How do we fix it? In this case, the files are being stored at temp data images, which is why we needed to go up 3 levels. So we went up images, data, temp, we're now in the root directory. Now we can go to etc. The code is in app.py, so let's just take a look at that. And this is now the Flask code of this web application that is serving the uploads. So there are a few different holes in here that we're going to patch up and fix. The first one is a logic bug. So we have these allowed extensions. Someone did think to limit us to just certain file types of trusted images. But it's not being used correctly. So where is it being used? Well, there's this helper method allowed file, and this function is saying return essentially a boolean, true or false. Return true if there's a dot in the file name, or the extension, what comes after the period, is in allowed extensions. Well, that's not quite right, because we don't want either of those to be true, we want both. So we're going to change this or to an and I'll save that file. And now what should we be able to do or not do? Well, in the example of demo.md, this doesn't match the trusted extensions, although it has one. So now we shouldn't be able to upload that. And sure enough, it just kicks us right back out. If I were to upload an image, great, we're still good. Actually, that was expected functionality I don't think we had tested, was upload the same image twice and see what happens. In this case, I believe it's just being overwritten, which is another potential security hole, depending on what you want the user interaction to be. I'd mentioned maximum content lengths. So let's go ahead and set a very strict maximum content length just to test this out. This is very easy to do in this case in Flask. We're just going to configure the app with this app level parameter. And this takes in the total number of bytes. Let me save that. And we're looking at 5 by 1000 essentially, so 5 kilobytes, which is an absurdly small size, unless maybe this is a tiny thumbnail image. So you'd probably set something larger, but let's just try this out for testing's sake. So we should be able to upload this one. This is a 2 kilobyte image. Should still work just fine. Great. Now let's make a larger image. So let's just make this 10 times as big. Great. It's now 37 kilobytes, so that's well beyond our 5K limit. See what happens. And it's not the best user experience. We should probably catch this server error and respond back accordingly with a happier message to the user. Upload a smaller file, please. The limit is such and such. But we know our functionality is working here. So next up, let's take a look at the routes here. We have as we saw before, we have this homepage route first. So this is at the base level directory. It either shows that page, or as a post request, we can upload our file. Below that, we have view and deliver, view and uploads. So this was our /view/ that file name, which gave us the here's your image and here's the source, which points to uploads. And finally, we had /uploads, which just delivers that file. Now you'll notice the file name is being taken into the URL directly and passed to uploads directly with no sanitization. We're not cleaning it up, checking for special characters. That could be okay if we did something reasonable with it here. But instead, we get it from the requested arguments. So when we did question mark file name equals blank, it's throwing that into this variable directly and sending the file by joining the uploads folder, that temp images folder, with whatever file name we supplied it. So here we need to escape user input, essentially. We need to, instead of just appending whatever file name they like onto this upload folder, we need to combine those two pieces securely. So we can use secure file name in Flask. And it's just that easy there. What this is going to do is say, if you have any dangerous characters like a /, it's going to turn that into an underscore so that it isn't interpreted as something more dangerous. We're going to do the same thing earlier on as well. So let's see here. In upload file, when we're originally submitting this file, likewise, we said the upload is just this file name directly. But right away, we should secure this file name. We should make sure that it has only safe expected content. Let's see here. Actually, what we should really do, I'm going to do this slightly later on because this might not be a file name yet. And we also want to check that this is an allowed file type before we sanitize it. So either should work, but let's do that here actually in upload.filename. Typically, what you'll want to do is sanitize input as quickly as possible, but in this case we have some logic that is, the only thing the logic is doing is checking that it is a safe file. So it makes sense to include in here. So I've saved that. And let's see. We should not be able to get to this now. And sure enough, it's giving us a server error because it's now changing these to different characters on the way out. Likewise, if we were to try to upload this file with a dash and a space, let's try that now. Ah, right, it's too big. Let's just get rid of that, make another copy. And it's not liking that at all. So I think I may have gotten, right. We actually have to import this functionality as well. And so to use secure file, instead of just sending it directly, we need to import this utility. Need to read my own instructions better. Utils, excuse me. Alright, and hopefully this may be another case of live coding where something doesn't work out quite. Oh, here we go. So you'll notice this time when I said small image with a space, it actually renamed that space even to an underscore. So it's making sure that that I have a secure file name as well. Okay. It looks like I've done something slightly different than I asked you to do here. So if anyone in Slack happens to notice it, let me know. But let me just check my work really quickly. So I've imported this, great. And in upload, I change it there, great. And finally, for aha. So in this case, it also makes sense when we deliver the uploads to make sure that we have a secure file name as well. And so we would change this, let's see, to the secure file name once we're delivering the upload directly. In this case, we'd already taken care of it earlier, but in terms of defense in depth, it makes sense to do every chance we get. Speaking of defense in depth, right now we're using send file here, and there's a better function in Flask that will again help sanitize inputs. So rather than just sending a file name, combining these two together, we can do send from directory. And what this is going to do is only allow you to upload files or to deliver files that are from the directory that you've specified. So this really leaves no chance for directory traversal here, because it'll check in the final state, is this in fact coming from the directory that we wanted it to be? And if not, it's going to disallow that and throw another server error. So instead of send file, we have send from directory here. And in this case, we're not actually going to see any change in behavior. We have already made sure that we're not susceptible to directory traversal. But it's a good idea to do this in general, because if this were, a more complicated application shared among multiple developers, you're increasing the different features available. It's very possible that we could insert a bug somewhere else, or a possible vulnerability somewhere else. And so as many layers as we can of proper security and proper checking that don't add any significant overhead, we should certainly add those in wherever they're easy to do like this. So are we secure? Well, we have one last check here. What were to happen if this were in production already, which in a sense it was, and someone uploaded some malicious content? In this case, they've uploaded file.pdf. Well, right now, we're not checking for allowed files on the delivery, and since we haven't deleted that content, it got past us before we were able to disallow that type of content. So this is a quick example of stored cross-site scripting. This PDF file has JavaScript that's popped up this alert box for me. And so even though we now have a much more secure app, it could still be delivering content that we don't want it to be. So we need to add the allowed file helper function into our actual delivery of the file as well. So as a really quick way to do that, I'll just say if allowed file, let's do this after we have the file name. Then we can send it along to the user. Otherwise, right now we won't do anything. But now if I try to get to this file, it'll again just give me a server error because we're now checking on the way out as well. Do we expect to be delivering this type of file? And if not, don't send that. Again, we should probably have a bit better error message. Maybe it doesn't matter in this case because this is an internal endpoint that they shouldn't be hitting anyway. But that's it for this lesson. So in terms of other next steps, you'll notice everything is happening over HTTP. So any sort of secure content, we should probably be doing that with TLS. We should be encrypting that traffic because we don't know, it could be content that someone doesn't want shared, and you should trust that they're being sniffed whenever it's in the clear. Another thing to note is rate limits. So beyond just can I upload really, really large files, what about can I upload files all the time, every day, all day, really quickly with multiple servers? That could be another possible denial of service or have all sorts of ramifications we don't want. With this particular application, this is open to the world and there's no session management. So do we want anyone on the web without even being tied to a user to be able to upload a file? Maybe not. Anything else? Curious if there are any thoughts, questions in Slack? Anything else to go over about this lesson in particular or the concepts involved? Otherwise, we can jump into a second one as well. Okay. It looks like we've just got the question about the Apache exploit. So I don't have a video on that, but we just posted the lesson on the platform. And it's not in, I don't believe it's in a module, but if you search for individual lessons, it's the last, most recently one published out there, and you can go ahead and try out that lesson on your own. The idea there is that it's a Tomcat server running a Java web application over struts, which is a web framework the same way that Flask is for Python. And there's a parser, an XML parser, in which you can insert code into content type headers and request headers that will actually get executed. So you can go all the way to getting a remote or a reverse shell on the server. So we won't go into that one right now, but that's a fun one to try out on your own. I will dive into, and we'll do a whirlwind tour of CSRF. Got a quick question: how do space characters pose a security risk? So they might pose a security risk in terms of some parser on the back end that is doing wonky things. Because it's not treating spaces properly, it's treating things after spaces properly. Most typically they won't by themselves. But if you were, again for defense in depth, if you were to have a vulnerability that would allow someone, for instance, to read the name of a file, you might actually prevent it by stopping them from inserting spaces so that they can't write out the code that they were hoping to run. So it's not a great security measure by itself to limit spaces, and it's not necessarily a vulnerability to allow them, but it's an additional safety measure when you're able and willing to rename the space characters. And it's really just sort of a design decision that they took in this case to say, let's be particularly aggressive in renaming anything that might cause some harm possibly down the way to a definitely safe character to use. So let's jump into cross-site request forgery. The standard example here is essentially it means that you're trusting, you're exploiting the trust that an application is putting in a user's browser. So for instance, if I were logged into my bank and someone sent me a link, that link potentially could cause an action for me because I'm already authenticated with my bank. And so in terms of cross-site, the idea is you're leveraging another user's valid credentials, a victim's valid credentials, or valid authentication, and causing them to take some action that you want them to take on your behalf. So this is a really simple Django application. It just has some posts by Alice and Bob here. And again, we're just going to test out known functionality first. So I'm given Bob's username and password here. So as I log in as Bob, you'll notice I can now delete Bob's posts. Let me open up my console, my network tab, and see what happens when I click delete. In fact, you can already see down here when I hover over it that it's just calling /delete/to. So I already have the ID of the post, it looks like, and it's just a GET request. It's not even a post or a put or a delete, meaning as soon as I go to that URL, make a GET request of that URL, it'll delete the post. So I clicked it, it's gone immediately, and you'll see the GET just redirected me to this new page and said 200, it's gone. So I'll log out of Bob and move forward here. We can take a look at some of the application code here, which is mostly in this folder here. I'll go to the views, the Django views, and this is where we've defined listing all the posts, creating a new post, and down here we have the function to delete a post. And you'll notice on the back end it's not doing any sort of checking about who owns the post and do you have access to delete this. So from the request and the ID, it's just saying, well, it is saying this is the current user. In that case it was Bob when I deleted his post. It'll get the post by the ID. It says let's make sure that this is the user's post, and it deletes it. So in this case, Bob can't delete Alice's posts because it's checking against who owns them. But it's not doing any additional check of did Alice mean to delete this post, or was this request made separately. So what typically happens with CSRF is it's a phishing email, or more often it's a button you click on a site so that it's making a post request. And this time it's just a GET. And so we can do that with just, in this example, we're setting an image source so that it's totally transparent to the user. They won't even notice that this request has necessarily been made. So let's just create an extremely basic HTML page. This is the full contents of the page. This is just saying an image where the source is this URL that I want you to visit. It won't be able to load an image from there, but it will visit this endpoint in the user's browser. So So let me save that as an HTML page. First, I'm going to log in as Alice. So this could, again, be her bank or something more sensitive. She now has the ability to delete her own posts. But in a separate window, let's say Alice were to visit this page, clicked on a link, opened an email. It could even be, viewed an email in her email inbox, depending on the email service you use. And this image loads. And sure enough, we don't see anything, but here it is. It tried to load in the image. And if I refresh this page, one of my posts has been deleted. So what do we do about this? Well, in this case, it was a bit contrived in that, excuse me, in that Django by default will protect you from this if you have good configuration settings, if you haven't screwed up a lot of the default settings that it will give you. The settings are in project settings, so let's take a look there. Oops. And this is all template code that gets generated when you create a new Django project using the sort of wizard tools that they allow you. And you'll see in this case we just commented out CSRF view middleware. And so this is going to add in to every form we create a CSRF token that will protect us. In this case, just commenting that out won't protect us because we just have a GET request. And so we can still visit that link directly. So we would also want to go back out to that delete post view and change it from using a GET to a post or a delete. And what would happen is it would create, this is Django templating language, but it would insert a random token, which is just a long random string that you can't easily guess. And it's going to check on the back end against the request that loaded this page. When I submitted my request to delete the message, did I also submit a CSRF token that matched? So did I take this random string that I was given and give it back to you? That's the equivalent of saying, when I loaded this page, I now have a one-time password, in a way, to allow me to delete here. And there's no way for someone outside, unless they're able to sniff my view of this page, to know what that random string is to allow this request to go through. Which is also important to note that sometimes CSRF, when it's implemented custom, CSRF protection doesn't use a very strong token, or it uses an easily guessable token. And so if I were a user and noticed that CSRF was, the CSRF token was very short, or something based on the username, it's really common to just perform a basic MD5 hash, for instance, of the username and the time. Well, I could actually guess that potentially, depending on the specificity there, and still send that link to a user or get them to click on, take an action on that link. And so it's very important to have the CSRF token be completely random and long enough to be not easily guessable. There's some more bugs left in here, but I'll leave that as an exercise to the reader, to the viewer, to the doer, hopefully, if you get in there and play around with it on your own. Because there are more routes, there's more functionality in this particular exercise that you can play around with and wreak havoc, and you can hopefully also then go out and patch on your own as well. So I think that wraps up the couple exercises we're going to go through this evening. I'll jump back over to Slack for any sort of Q&A, and we'll also post this as a recording later on if you want to review it later, or you came in late and want to take a look at parts that you missed. I'll post that in Slack as well. And thanks for watching. Hope it was informative. And again, you can go out to ex.whitehat.academy and try all of these out on your own. Welcome any sort of feedback on how it was, any features, any content you'd like to see next, because we'll be building out more lessons and challenges soon. Thanks so much.